Welcome to today's physics lesson. In our lesson for today, we'll be talking about electricity, and specifically we'll be talking about circuits. So in physics, when we talk about electricity, we talk about quite a number of concepts that we are going to be discussing as we progress. But today we just want to answer this simple question that came in one of the past papers, where we are given a circuit, and then the question is saying the diagram below shows resistors connected to a 4 volts power supply. So as you can see here in our diagram, we are having our first resistor, our second resistor, and our third resistor. So looking at the circuit that we are having there, these resistors that we are having, they are connected in both series and in parallel. So if you can see this one is connected in series, while these two are connected in parallel. So now, how do we solve the first question that we are having there, which is what is the effective resistance of the circuit? So in short here, they want us to calculate for the total resistance for the entire circuit. But now we are having resistors that are connected in series and those ones that are connected in parallel. We know to say when you're having resistors that are connected in series, for example, they are like this. To find the total resistance here, we know to say we are going to find the summation of all the resistors that we are having. So meaning we are going to add this one plus this one plus that one. We are going to say this is R1 plus R2 plus R3. This is how we obtain the total resistance if the components, or rather the resistors, are connected in series. So if these resistors that we are having, they are connected in series, we know to say to find the total resistance, we need to add all the values of the resistors that we are having. But now, what of if we are given resistors that are now connected in parallel? If this is our power supply, for example, then now we are having resistors that are connected in parallel, like this. If this is our first resistor, this is our second resistor, and this is our third resistor. How do we then find the resistance for the entire circuit? So to find the total resistance there, we are going to say R1 times R2 times R3. This is over R1 plus R2 plus R3. So meaning the first resistance multiplied by the second one, multiplied by the third one, then divided by their summation, meaning we are going to add R1 plus R2 plus R3. So basically, these are the two concepts that we are going to apply on the circuit diagram that we are given. So now, following the same question that we are given there, as we can see, the 3 ohm resistor, this one here, our first resistor is connected in series. But these two are connected in parallel. So in order for us to find the total resistance in the circuit, we are going to add this to that. So as we know, to find the total resistance there, we are going to say our R1, which is connected in series. So we are going to add that one to the total resistance that is here, where they are connected in parallel. So there, as we discussed previously here, we are going to say this is R2 times R3 over R2 plus R3. Why? Because those two are connected in parallel and this one is connected in series. So we are going to say this should be equivalent to the one that is connected in parallel, which is, in series, sorry, which is basically our first resistor is 3 ohms. Then this is plus second resistor, that one it is 6 times our third resistor is 12 ohms. This is over our second resistor is 6 plus our third resistor is 12. So let's not swap this, because we know to say on top we are multiplying, but down we are adding. Then we are going to say 3 plus, what is 6 times 12? So 6 times 12 we are getting 72 2 over our 6 plus 12, we are going to get 18. So we know to say 18 can go into 72. So we are going to say 18 into 72, we are going to get 4. So this will be equivalent to 3 plus 4, we are going to get 7 ohms. So meaning the effective resistance, or rather the total resistance through this circuit is what? 7 ohms. But now, to answer this question, which is question number B, where we know to say, they are telling us to say calculate the potential difference across the 3 ohm resistor. So they just want us to calculate the what? The potential difference, or rather the voltage through our 3 ohm resistor. So in order for us to find the voltage there, we first need to find the total current that is passing through the circuit. So in order for us to do that, we follow Ohm's law, which tells us to say our voltage is directly proportional to our current and then our resistance. So we don't say our voltage there, that is 4, that will be equivalent to our current, we don't know. Then the total resistance there, we know to say it is what? 7, because we found 7. So we are going to say 4 will be equivalent to 7 times current, we are going to get 7I. Then we say now over 7 over 7. This and that will go. Our current will be equivalent to what is 4 divided by 7. We are going to get 0.57 to 2 decimal places. So this is the current that we found for the entire circuit, this one, which is the total current. So now, in order for us to find the potential difference that is passing through the 3 ohms resistor, we are still going to stick to what? Ohm's law. So Ohm's law will always guide us by voltage is equivalent to current times what? Resistance. So now, in this case, we are finding voltage through the 3 ohms resistor. So meaning the current through the circuit is what? 0.57 multiplied by the resistance. Now we are just focusing on the 3 ohm resistor, which is going to be 3. So this will be equivalent to what is 0.757 times 3. We get 1.71 volts. So meaning this is the voltage that is passing through the 3 ohm resistor. To prove if your answer is correct, or rather you are doing the correct thing, you are also going to find the total voltage that is passing through these 2 resistors. Then after you do that, you add it with this one, it should give you what? 4 volts. So otherwise, basically, this is how you solve, or rather handle questions that are dealing with resistors that are connected in a circuit. So thank you very much for tuning in today. See you next time.